So now that we looked at what inscribed angles are, there's a couple other what are called corollaries to this idea. Now, corollaries are kind of properties that we see will always be true because of these properties of inscribed angles. And so you see 3 listed here. These are in your student note sheet. If you don't have that student note sheet, make sure you get these written down. The first one, we saw an example of this. 2 inscribed angles that are intercepting the same arc have to be congruent, right? If both of those angles are 1/2 of the arc, they both have to be the same measurement. The second one, an angle inscribed in a semicircle is a right angle, right? And we also looked at an example like this. If the semicircle is 180, then that angle of the inscribed angle has to always be 90. So any kind of triangle or inscribed angle that you see that's cutting that circle in half, here you can notice there's a line. Get my writer. Anytime you see this kind of happen where we're finding an angle, it's always going to be a right angle, no matter if it hits over here or where this A is or even right up here. It will always be a 90-degree angle. Okay, and then opposite angles of an inscribed quadrilateral are supplementary. So this angle and this angle have to be supplementary, right? If they are taking 2 different parts of that circle all the way around, they're going to be supplementary to each other. And likewise, these 2 angles are going to be supplementary. Okay, so these are those corollaries. So if we're looking for some values and we know these corollaries, they can help us to be a little bit faster in our calculation. So for example, if we're finding ACB, we're looking for this one, remember that we already know this is 90. And so then without even needing to know any of the arc measures, well, if this is 90 and this is 31, then we know that this must be 59, right? They have to add up to 180. Likewise, if we're trying to find this angle over here and we have its opposite angle, we know that these 2 angles must be supplementary, meaning they add up to 180. So then we know that this one must be 128. We could find those measures without even knowing anything about the arc lengths. Okay, and then here's another really important equation that we're gonna use. And this one deals with an angle that is formed by a chord. Here's our chord and a tangent. And so anytime you see a chord and a tangent, it is half the measure of the intercepted arc. So you see 2 different equations here, but they're both telling us that it's half the measure. The angle is half the measure of the intercepted arc, which means if we're looking at EAB, whatever this arc is here, EAB is going to be half of it. And if we're looking for DAB, say that this arc out here that goes all the way around, say that this was a 2x, right? Then that angle is going to be a value of x. It's always 1/2 of that intercepted arc where the chord cuts our circle in half. So let's look at some examples of this. So we are told here that ADC, this part around here, is going to be 210. I want you to first realize that if we know that, then we also know that this part over here must be 150, right? We know that they're going to add up to 360. And so if we want to find this angle, which is between a chord and a tangent, it's going to be 1/2 of the intercepted arc. So in this case, it's going to be 75. Now, we're not asked to find the other angle here, but if we were, we know that that arc is 210, which means this angle here would have to be 105 degrees. Okay, so the same kind of idea that we looked at with those intercepted angles, but our angle is created a different way. Okay, if BD is tangent to C, and we know that AC, this arc right here, is 88. If we're then looking for this angle, we know it has to be half, so this angle is going to be 44. Okay, I want you to take a minute and try to see if you can solve this part B before you watch the answer. Go ahead and pause the video and solve part B. Okay, hopefully you tried this one on your own. This time we're looking at this tangent here. And we are told that GFC, so this angle, is 115. And if that's 115, it means that this arc that goes from that tangent all the way to the other side of the chord has to be twice as much, will be 230. Okay, so the angle is always half of the arc. This is just kind of recapping what we looked at, right? So you should have some notes from today on inscribed angles, as well as our equation. And you should have this property about tangents and a chord along with this other equation. And when you finish getting these notes down, this is what I want you to do next. Send me a message in the chat and let me know that you're finished. Then take a picture or a screenshot of your notes from today. They should have all those key things in it. So make sure that your notes have those pictures, some examples, some equations, and email me either a picture or a screenshot of your notes. And then once those two things are done, you can go ahead and get started on the practice for today.